All right, guys, hopefully yesterday went okay for you. I know it can be challenging doing these equations, and you have to have a unit circle handy, which I just realized I don't have. So on my, I'm going to add a page here on my presentation, and I will go ahead, and this is the sort of thing I should have done ahead of time, but I went ahead and started to record, so here we go. Let me find the unit circle. There, stretch it out so it's easier to see, and maybe I'll move it down the page a little bit. There we go. So this I can refer back to as we go. Okay, so advanced trig equations. If you haven't yet viewed 7.4, you really need to do that first because this builds on that. So these are advanced. There's going to be more solving techniques involved. We're going to need one side of the equation to equal 0. And then from there, we'll do either common factoring or trinomial factoring. Common factoring is something like if you have 5x squared plus 20, you can factor out the 5 and get x squared plus 4. That's common factoring. Trinomial factoring is like if you have x squared plus 2x, or well, let's make that 3x plus 2. You can sort of unfoil it to make it xx plus 2 plus 1. So that's those kinds of factoring in algebra. We're just going to be doing it using trig. That'll be fun. On this assignment, we'll use all 6 inverse trig functions. Yesterday, to keep things simple, it was just sine, cosine, and tangent. That's it. But we are going to use the other 3 today. All exercises on this assignment, the answers will be between 0 and 2 pi. So you don't have to switch back and forth between degrees and radians. We'll just make everything radians, keep it consistent. You're going to want to use the unit circle. You can use the calculator to help give you tips every now and then. Excuse me, but the unit circle is going to be better. And then finally, if you get cosecant x equals a number, the way to make the unit circle go a little easier is to think of it as sine and just invert whatever that number is. So what I'm saying is if you end up with something like cosecant inverse of x equals 1/2, or well, that's not going to be a thing, let's say 2, then you can just change it into sine inverse equals 1/2 because cosecant and sine are reciprocals of each other, right? Cosecant is hypotenuse over opposite, and sine is opposite, opposite over hypotenuse. So they're just inverses or reciprocals of each other. So to make the unit circle go a little easier, you can just reciprocate those. Similarly, if you get secant equals a number, I'm using a here, just a random variable, but you know, any number, a stands for any number there. You can do cosine equals 1 over a. So what I'm trying to say is, yesterday we did everything with sine, cosine, and tangent. You can interpret cosecant as sine and secant as cosine, which kind of puts us back to the main 3. You still have to do tangent as x over y, cotangent as x over y, whereas tangent is y over x. You could do the same trick, turn cotangent into tangent, just flip it over, but at that point you're not saving any steps, whereas with these you might, with secant and cosecant, you might be saving steps. Okay, if that made no sense to you and I'm just rambling, wait till we get to an actual example. Hopefully it'll become better and easier. Let me just get rid of these random notes here, and we'll get to the examples. Okay, so there's my copy of the unit circle, and here are the exercises. And how many do we have? 12. So not near as lengthy as yesterday. That's probably a good thing. Okay, so here we have this mess. So the first thing we want is we want one side to equal 0. Here's what I'm going to do. I am going to add 2 secant squared theta to both sides to get like terms together. Negative 1 secant squared theta plus 2 secant squared theta is 1 secant squared theta. Now, could I have added this over to that side? Yeah, but I would have had a negative, and I don't like that. Now, to make one side equal to 0, I can subtract secant theta on both sides, and I can subtract 2 on both sides, This all cancels out, gives me 0 equals secant squared theta minus secant theta minus 2. So we have one side equal to 0. Now from here, there's a couple techniques you can use. I'm going to use a technique called a u substitution. Let u equal secant theta. What that means is I can rewrite this problem instead of secant squared, it's u squared. Minus secant theta is just minus u minus 2. When it's written this way, it just looks easier to factor. U. We need two numbers that'll multiply to -2 and add up to -1. So that's going to be -2 plus 1. So writing down the secant theta over and over is too long, too complicated. Just temporarily make it u. Now, when you have a quadratic like this equal to 0, you set each one equal to 0. U minus 2 equals 0, each factor. And u plus 1 equals 0. So I set this factor equal to 0, that factor equal to 0. Solve them both. 2 equals u, and -1 equals u. Now, that u substitution is temporary. The problem is not really built around the variable u, it's built around secant. So I'm going to change it back. U is secant, and this u is secant. So we now have it most of the way solved. What's left? Well, to isolate theta, I'm going to have to do the inverse secant. So I'm going to do inverse secant here to cancel that out. The inverse secant of 2 equals theta. Here do the inverse secant of both sides. Cancel that out. Theta equals the inverse secant of -1. And let me make that theta look more like a theta. There we go. So now we go to the unit circle. But again, the unit circle is real good because we know x is cosine, y is sine, tangent is y divided by x. The unit circle isn't really built around secant and cosecant. So what I set up here is if secant of x equals a, then cosine inverse of x equals 1 over a. In other words, I can change this to cosine inverse of 1/2 equals theta, and cosine inverse of, well, if I flip -1 over, it's -1 over 1, so it's still -1. So I want to now do cosine on the unit circle, which is an x value. I need to find an x value that equals 1/2 and an x value that equals -1. So let's do this. X value that equals 1/2, that's right here and right here. So I get the angles pi over 3 and 5 pi over 3. So this part of the problem gives me, boy, I'm running out of room to write this. That is awful. Let me shrink some things down a little bit real quick. Ugh, that didn't work very well. What the hey, guys? Oh my goodness, it's not going to work for me. Ugh. Okay, I don't know why that's doing that. Oh well, I'll just deal with it. I'll erase this x here. So theta worked out to be, well, now I already forgot, pi over 3 and 5 pi over 3. Pi over 3 and 5 pi over 3. But this part of the equation over here, I'm looking for an x value that equals -1. Where on the unit circle does x equal -1? That's right there, and the angle is pi. So from this part of the equation, I get theta equals pi. So I come up with 3 answers: pi over 3, 5 pi over 3, and pi. Let me check number 2 and see if that's right. Pi over 3, pi, 5 pi over 3. Right answer is just written in a different order. So let me review how this was done. you need one side to equal 0. So do whatever algebra steps you need to do by adding, subtracting things to move them from one side to the other. What you get is, in this case, a quadratic. Quadratic means there's something squared. The variable is squared. Solving a quadratic involves factoring. To make the factoring look easier, we do this thing called a u substitution. Take out the secant and just call it u. Do your busy work, your algebra 2 manipulation using the letter u to make all that go quicker or easier or whatever you want to call it. And then at the end, turn the u back into secant and keep doing the trig like we did yesterday. Finally, if you get a secant or a cosecant, just flip it and change it to cosine or sine, depending on which one you're doing, and there you go. Okay, let's try number 4. So what's going on here? Well, let's make one side equal 0. Do we have any like terms to get together? Yeah, we can, oops, go minus 3, minus 3. We get 4 sine squared theta plus 1 equals 4 sine theta. But from here I can subtract 4 sine theta on both sides. Or you know what? Here's an idea. Let's go ahead and do the u substitution from the very beginning. What am I trying to do? Let's delete this. Let's just start this problem over. Let's let u equal sine theta. So this becomes 4u squared plus 4 equals 4u plus 3. So sine theta turned into a u, sine theta turned into a u. Now it might be a little easier to see how things are going to work. Minus 3, 4u squared plus 1 equals 4u, minus 4u on both sides. 4u squared minus 4u plus 1 equals 0. Now this we can solve by factoring. You put a 4u here and a u there, and then you're like, okay, how can I make the rest of this work? Okay, I put a 1 here and a 1 here. Well, that'd have to be a minus minus, and if I multiply the outside I get negative 4u, and the inside I get negative 1u, and those combine to negative 5u, not negative 4u. So it turns out this won't factor. Well, it doesn't factor. What the heck are you supposed to do? Gosh, this is awful. Well, I hate to break it to you, but we get to do the quadratic formula. So in case it's been a while and you forgot, negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, all right, oops, sorry, b is negative, I'm sorry, negative b, and b is already a negative 4, so the double negative turns it into a positive 4, plus or minus negative 4 squared minus 4 times 1, all divided by 4 times 2. Oh, darn it, that would factor. I'm so silly. I could have factored that. I wasn't thinking it through clearly. Oh well, I already started the quadratic formula, might as well finish it. So this works out to be 16 minus 16 over 8. So that's 4 plus or minus the square root of 0 over 8. 4 plus 0 and 4 minus 0 is the same thing. That just gives me 4 over 8, which is 1/2. So, goodness, I get u equals 1/2 is my answer. That was a whole bunch of work, unnecessary quadratic formula work. Oh well, it's not like you're dumb and you can't handle it. You can handle seeing me do the quadratic formula. It's fine. All right, so now the u was sine, so I can substitute that back in. Sine of theta equals 1/2. To solve this, I need to cancel out sine, so that means I need to do the inverse sine of both sides. Theta equals the inverse sine of 1/2. On the unit circle, sine is a y value. So let's go to the unit circle and find any y values that equal 1/2. Where is that at? Looks like right here and right here. So that means 30 degrees or pi over 6, right? This worksheet is all in radians, so pi over 6 and 5 pi over 6. Those ought to be the answers. theta equals pi over 6 and 5 pi over 6. Let me check that, and we are correct. Okay, I have to admit, I feel really, really dumb about doing the quadratic formula on this equation. If you're good, you can move on to number 6, fast forward the video to there. I'm going to redo this doing factoring. So I'm going to pretend like I never was dumb and never bothered doing all of that work. How do you factor this? My first attempt failed, and I just assumed I was wrong. I did 4u and u, and I tried -1 and -1. It didn't work. Well, that's not the only option. You can also try 2u and 2u. Well, here, if you multiply the outside, you get -2u, and the inside is -2u, and those combine to -4u, which is exactly what you want. So, duh, that's how it factors. Now you set each one of these equal to 0, and they're the same thing, so you only have to solve one of them, and you get u equals 1/2. I mean, this one, if you did all the work, it would also come up to u equals 1/2, whatever. But now you can do the u substitution, so plug sine back in. Sine of theta equals 1/2, right? Let me come up here. If sine of theta equals 1/2, why did I write the equal sign like that? Now I can do the inverse sine of both sides. And remember, sine is a y value, so we're looking for a y value that equals 1/2. You go back up to the unit circle, and it plays out the exact same way. Oops. Right, so everything's the same, it's all good. So yeah, factoring is usually easier than the quadratic formula. Okay. Number 6. Again, this is a quadratic because of the square, so I'm going to go ahead and do my u substitution. U equals cotangent theta. So 1 equals -u squared plus 2u. Again, to start these equations, you need one side to equal 0. Now, I could just subtract the 1 over to this side, but that gives me -u squared. And honestly, you want to avoid that. You don't want to have the squared term in a quadratic be negative. I mean, you can, but it makes the work less fun, less easy, less desirable. So instead of that, I'm going to go ahead and add u squared over to this side, and I'm going to subtract 2u. So all this cancels out. I get equals 0 on the right, and on the left, I end up with u squared minus 2u plus 1. There we go. Now I can try to factor this, u and u, and it looks like 1 times 1 is 1, -1 plus -1 is 2. Set each one of these equal to 0, and it's kind of like the last problem. If you set them both equal to 0, they're both the same, so you really only need to solve one of them. U equals 1. Now, u was cotangent, so switch it back to cotangent. To solve this, therefore, I'm going to have to do the inverse cotangent to cancel that out. And the question is, what is the inverse cotangent of 1? Well, cotangent is defined as, on the unit circle, as x divided by y. So we're looking for what two numbers, when you divide them, give you a 1. Well, in math, the only way to divide two numbers and get 1 is if both numbers are the same. So we want to find any coordinates up there where the x and the y coordinates are the same. And that happens in two places. Right here, they're the same, and down there, they're the same. Those are both 45-degree reference angles, or pi over 4 reference angles. You might ponder this one for just a moment and say, hey, they look the same, but no, one's negative, one's positive. So technically, they're not the same. So it's, and then the same thing goes for these two down here. Same numbers, but not the same because one's positive, one's negative. So we get two answers, pi over 4 and 5 pi over 4. So theta equals pi over 4 and 5 pi over 4. Check the answer and move on. That's easy for me to say. There we go. All right, so those were all quadratics. Quadratic means there's something squared, and this u substitution is supposed to make things go easier. The next, well, the whole rest of the worksheet is not quadratics, so we're not going to do the whole u substitution thing. We do still want one side to equal 0, however. So let's say on this one, I'm going to add 2 cotangent theta to both sides of the equal sign, and turns out that those are like terms, right? Now these aren't like terms because this is attached to cosine theta, which is unlike. It's like having a whole different variable there. But those are like terms, so they go together. I get 0 equals negative radical 2 cotangent theta cosine theta plus 1 cotangent theta, right? Negative 1 plus 2 is positive 1. So to solve this, we're going to do common factoring. Remember, common factoring is like this, where both terms in this case were divisible by 5, so I divided a 5 out. It's almost like the distributive property done in reverse. So you look at this, you either want to say, okay, what is in common that can be factored out, or what can I undistribute out of this? And so this is a term, this is a term. They're separated by that plus sign. And what do they have in common? I'll highlight that in a different color. Cotangent theta is in common. So I'm going to factor out a cotangent theta from that whole expression, and that's going to leave me with negative radical 2 cosine theta plus 1. If you have cotangent and you divide out a cotangent, cotangent divided by cotangent is 1. That's where that 1 comes from. Now that it's factored, set each factor equal to 0. 0 equals cotangent theta, and 0 equals negative square root of 2 cosine theta plus 1. So I set this equal to 0, and I set that equal to 0. Here, I just need to isolate theta by doing an inverse cotangent on both sides. To cancel out the cotangent, I get theta equals the inverse cotangent of 0. For the other one, this is going to take some steps. I need to minus 1 on both sides. Negative 1 equals negative square root of 2 times cosine theta. Then divide both sides by 1 over square root of 2, or divide both sides by square root of 2. Cancel that out. So I get cosine theta, forgot the s, cosine theta equals, and these negatives cancel out, 1 over square root of 2. But wait, stupid math, can't have a square root on the bottom of a fraction. I need to multiply both sides by radical 2 over radical 2. So that gives me top times top is square root of 2. Bottom times bottom is going to be square root of 4, right? 2 times 2 is 4. The square root of 4 is 2. Now, cancel out cosine. How? With an inverse cosine. So the inverse cosine of radical 2 over 2 equals theta. Now is where I go to my unit circle. First, cotangent. Cotangent is x divided by y. In order to divide two numbers and get 0, the top number has to be a 0. So I need to find anywhere on the unit circle where x is 0. Where does that happen? Let me erase a bunch of this scribble. Where does x equal 0? Nope, right here and right here, right? So cotangent is x divided by y. So 0 divided by 1 equals 0. And down here, 0 divided by negative 1 equals 0. So I come up with two answers, 3 pi over 2 and pi over 2. So let me go to the original problem. From this part, I get theta equals pi over 2 and 3 pi over 2. Okay? Now let's go to this part. Inverse cosine of square root of 2 over 2. Cosine is an x value. So I want to find an x value that equals square root of 2 over 2. Let me go up to the unit circle. Here. Not here, because that's negative. Not there, that one's negative. And here. So 45 degrees, 315. No, got to do radians. Sorry. Pi over 4 and 7 pi over 4. Pi over 4, 7 pi over 4. Theta equals pi over 4, 7 pi over 4. So apparently, this equation has 4 answers. Let me scroll down and check. And here we go. Pi over 4, 7 pi over 4, pi over 2, 3 pi over 2. Wow, that's a lot of work. Ugh. And look at this one. Ugh, it just scares me to look at. So, well, I see that this and this are like. So if I combine them by subtracting 2 secant theta, this cancels out, gives me 0. That also cancels out. So I get radical 3 secant theta minus 3 secant theta cotangent theta. Okay, that's not so bad, except that I forgot the c in secant. Now, there's no squares here, so I'm not going to do the u substitution and the trinomial factoring. I need to do common factoring. So what do these terms have in common? They both have a secant theta. They almost also both have a 3, but that's a radical 3. So that's actually a different number. It's not a 3. So all I can do with common factoring is pull out secant theta. And if I do that, it leaves me with radical 3 minus 3 cotangent theta. Okay, so now I need to set each factor equal to 0. Set this one equal to 0. 0 equals secant theta. And set this whole thing equal to 0. 0 equals radical 3 minus 3 cotangent theta. Okay, for the first one to solve it, it's pretty simple. All I have to do is the inverse secant of both sides. Cancel that out. Inverse secant of 0 equals theta. And recall, for secant, you're best off turning it into cosine, or inverse cosine. So let me go back up to the notes and show you where that's written. Right here. If you've got inverse secant, change it to inverse cosine. You just have to take the a and flip it over, make it a reciprocal. So here the a is a 0. To make a reciprocal, that's 1 over 0 equals theta. And real quick, you can't have 1 over 0. That's undefined. So in other words, this half of the work yields no solution. So I can't take this to the unit circle and find an x value that equals 1 over 0. It's impossible. It doesn't exist. So that part of the equation is, I don't know, what you call it, fruitless. We get nothing out of it, whatever. But that doesn't mean that there's no equation or no solution at all. In fact, if I scroll down to number 10, I bet there's going to be solutions there. Yeah. But there's not like 4 of them like there was in the last problem. See, half of our answer is sort of disqualified, but not the other half. So we need to solve this. So I'm going to subtract radical 3 on both sides, then divide by negative 3, because that is times. Cancels out, cancels out. Here the negatives cancel out. I get radical 3 over 3 equals cotangent theta. That looks funky. And now to solve this, I need to do the inverse cotangent of both sides. Cancels that out. The inverse cotangent, not cosine, cotangent of square root of 3 over 3. Now, cotangent, again, is x over y. So x over y equals square root of 3 over 3. You might look at this and say, okay, I'm looking for an x value that equals square root of 3 and a y value that equals 3, like as in a point. But that's not going to happen. That's not anywhere on the unit circle. You want to find an x and y that when you divide them simplifies to square root of 3 over 3. So first let's talk quadrants. Square root of 3 over 3 is positive. The only way to divide two numbers to get positive is if they're both positive or if they're both negative. So we need to find the quadrants where the x and y are both positive or both negative. Well, that's kind of highlighted here and here. So our answers, here, let me get rid of this other stuff. Delete that, erase that, erase that. Our answers have to be in either the first quadrant or the third quadrant. Now, we need to divide them to get square root of 3 over 3. So our points have to have a square root of 3 in there somewhere. So if we're in the first and third quadrant, we're not looking at this point or this point, this one or this one. We're in the first and third quadrant. Well, it can't be here, square root of 2 over 2, square root of 2 over 2. If you divide those, you get 1. And it can't be this point. It's got to be one of the points with a square root of 3 in it. So again, cotangent is x over y. If I go to this one and I do the x value over the y value, oh man, what is wrong with me? It's been a long day and it's still a morning. I got that backwards. Let's go to this one. This is the x value, this is the y value. I said backwards, by the way. Don't report me for swearing on tape. Backwards, it's just a silly thing to say. Anyway, so cotangent is x divided by y. So if I take the x divided by the y, the halves cancel and I get square root of 3 over 1. Is that what I'm looking for down here? Square root of 3 over 1? Where am I? Gosh, too much scrolling. No, I'm not looking for square root of 3 over 1. I'm looking for square root of 3 over 3. So let's go to the other point. X, y. X over y is 1/2 over square root of 3 over 2. Again, the halves cancel. We get 1 over square root of 3. And then we have that fun rule in math that says you can't have a radical in the bottom of a fraction, so you have to rationalize it. Top times top, square root of 3. Bottom times bottom, square root of 9, but the square root of 9 is 3. And there it is. So this is one of the answers. Now that's a 60-degree reference angle, pi over 3 reference angle, which means in this quadrant we want to do the same reference angle. So we don't have to do the whole x, y, divide it, work it out. We just know that that's going to be the other answer. So pi over 3 and 4 pi over 3 should be the solutions. Pi over 3, 4 pi over 3. Man, pretend like I can actually write in the English language. All right, number 10, pi over 3, 4 pi over 3. There it is. All right, next one and we're done. Yeah, we need one side to equal 0. So I'm going to minus tangent from this side. Cancel that out. That'll give me 0. I have to minus tangent from this side as well. Negative tangent minus tangent is negative 2 tangent. Plus square root of 2 tangent cosecant equals 0. Oh, you know what? Number 12 is going to be a lot like number 10. If you understood number 10, you can be done because number 12 is the same. If you struggled on number 10, number 12 is going to be repetitive. Sometimes repetition can help. Let me rewrite this a little more neatly. A little neater, however you're supposed to say that. Okay, so got one side equal to 0. I see a common factor, tangent and tangent. So I'm going to factor out tangent. When I do, that leaves negative 2 plus radical 2 cosecant equals 0. Set each one of these factors, tangent equal to 0 and negative 2 plus radical 2 cosecant equal to 0. Solve them both. To solve this one, I need to take the inverse tangent of both sides. Theta equals the inverse tangent of 0. Now tangent, of course, is y over x. So I want to find a y over x that equals 0. The only way for that to happen is if y equals 0. For a fraction to equal 0, the top has to be a 0. So is there anywhere on the unit circle that y equals 0? Let me get rid of all of this, y equals 0. Well, right there and right there. So that looks like it's going to be 0 and pi. I'm going to cheat and check the answers and see if 0 and pi, they're not there. Ooh, something is wrong. I done messed up. I'm going to write it down, 0 and pi. Then we'll go ahead and solve this part here. So add 2 to both sides. Square root of 2 cosecant theta equals 2. Divide both sides by square root of 2. Cosecant theta equals 2 over the square root of 2. Do the inverse cosecant of both sides. To cancel that out, cosecant inverse of 2 over the square root of 2. And remember, for cosecant, what you really want to treat that as is a sine problem. So, right, cosecant becomes sine. You just have to reciprocate it. Oops, didn't mean to close the window. Window. This is Apple. We don't do Windows in Apple, for crying out loud. Anyway, theta equals, so change this to inverse sine of square root of 2 over 2. And by inverting that, it also puts the radical in the top, which is a good thing. So now, what is sine? Sine is a y value. So we're looking for a y value that equals the square root of 2 over 2. Where on the unit circle is there a y value that's square root of 2 over 2? Looks like right here and right here. So that's pi over 4 and 3 pi over 4. So for number 12, I get pi over 4 and 3 pi over 4. What's the answer key say for number 12? It didn't. Pi over 4 and 3 pi over 4, but it doesn't give me the 0 and the pi. So why not? The directions say all answers between 0 and 2 pi, so that just means your answers are on the unit circle. The answer key only likes those. Yeah, I don't know what's going on here. And I don't know, am I ashamed to say it? Let's see, I moved my tangent over to this side. -1 minus 1 is -2 tangent. Factor out the tangent from here and here. Look, if you need to stop the video and get to work, go ahead. I'm going to troubleshoot this and see what's wrong, so stick with the video as long as you feel you need to. Inverse tangent of 0 let me go to a calculator and do the inverse tangent of 0. Function inverse tangent of 0. And it gives me 0, which is one of the answers. As we know, the calculator only gives you one answer. It doesn't give you two. So the unit circle gives us the other answer. So I'm going to say that the answer would have to be all 4 of these, and there must be some problem with the answer key. The problem is we use this software that's almost never wrong to create the worksheets. So I'm going to ponder this a while. I'll make some sort of an announcement. Yeah, I'm just a little stumped here. But go ahead and do try the rest of the assignment. If you have any discrepancies with your answer and the answer key, don't just assume the answer key is wrong because it happened once, but it's a possibility. The answer key could be wrong. All right, I think I'm going to move this over a little bit so that you have more room to work. But yeah, I'm going to stop here. Let me know if you have questions, and I will, if I find an explanation to number 12, I'll post it as an announcement somewhere. Otherwise, I'm going to stop. Good luck on this. Contact me if you have problems. When we do our Google Meets, which are on Tuesday and Friday, remember they're optional. If this assignment is too tough, we'll go and do the whole assignment during a Google Meet. So keep that in mind. Otherwise, I'll talk to you later.